Welcome back. This is Mr. Alexander solving the Unit 3 test review. I left off on number 7, and now we're jumping into number 8 on the test review. So we have some function that's in conic form. X plus 2 squared equals 8, y minus 1. And we're supposed to find 6 things, right? The concavity, the value of p, the location of the vertex, the location of the focus, the equation of the directrix, and the equation of the axis of symmetry. Well, it's already given us the equation, so the easiest thing to find is the vertex. I've got my x and my y. Now these are both in parentheses, so they're both counterintuitive. So that's the x value of the vertex is -2, and the y coordinate of the vertex is +1. Now the next thing I need to know to be able to answer the rest of these questions is the p-value. And hopefully you recognize that this right here, that 8, equals 4p, because if you remember from the equation is x minus h squared equals 4p y minus k. So I know that's an 8, so that's 4p. To find the p, we just divide both sides by 4, and you get p equals 2. Now, I can actually do one more thing before I need to go to my graph, and it's the concavity. Now, hopefully you recognize this as an x squared, which means it either opens upwards or it opens downwards. And it depends on what the value of p is. When p is positive, it goes upwards. If p is negative, it goes downwards. So since this p is positive, we know that this thing is concave up. Now to do the rest, I'm actually going to use one of these graphs that I put down here, and I just want to put on here. So we know that the vertex is at -2, 1, which is right there. That's your vertex. And the value of p is 2, which means to get the focus and the directrix, we just go 2 in either direction. Now we already said this thing is concave up, which means that the focus is going to be above it and the directrix is going to be below it. So now we just need to identify these points here. This focus is at -2, 3, and this directrix is going to be y equals, and it looks like I'm at -1. So I can go after graphing it, and I don't need to, but if I was to, this thing would look something like this. Your graphs aren't going to be graded, but if you want to freehand it, then you can, if that helps you see it a little bit better. But we did all that so that we could just come back up here and write the location of the focus. Well, we just did that on the graph. We said that was -2, 3, and we got that by going from the vertex up to the focus. We said the p-value is 2, so we went up 2. To get the directrix, we went from the vertex and we went down 2. So that directrix is y equals -1. And then the axis of symmetry is the line that cuts right through the center of this parabola, splits it right in half. So that's going to be an x equals something, and it goes through the vertex, so it's the x value of the vertex. X equals -2. All right, let's talk about number 9. Different parabola. This time it's going to be a y squared. Y minus 3 squared equals -16 x minus 5. So I like to start with the vertex, since it's given to us. The vertex, the x coordinate, is going to be +5, since it's counterintuitive inside parentheses, and the y coordinate is going to be +3. I like to do the p-value next. And I'm going to take this -16 to get that p-value. I'm going to say, okay, 4p equals -16. And I'm just going to divide both sides by 4 to get p equals -4. And I can use that information to get the rest of this. So first off, though, we can do the concavity. Since it's y squared, it's either left or right. And in this case, since it's negative, the p-value is negative, we're going to say this thing is concave left. All right, so let's just start putting down some of the stuff we know here. We know 1, 2, 3, 4, 5, up 1, 2, 3 for the vertex. And I know my p-value is -4, which means that my focus is going to be to the left for 1, 2, 3, 4. And my directrix is going to be to the right for 1, 2, 3, 4. So this thing kind of looks something like this. And now we just simply need to identify those points. The location of the vertex looks to be at 1, 3. The equation of the directrix is y equals, sorry, this is going to be x equals, isn't it? Because that's a straight up and down line. X equals 9. The equation of the axis of symmetry is this line that cuts this thing right down the center. That's going to be y equals something, and the something is 3. And so that's how you do number 9. Let's go on to page 3. Alright, number 10 says, for what value of c will the graphs of y equals 3x squared minus 24x plus c and y equals 3 times x minus 4 squared minus 6 be the same? So your c value is this thing. It's that bit on the end. Here's what I'm thinking. If we take this one, I'm just going to take this equation, and I'm going to factor it out. I'm going to FOIL it out even, and I'm going to try and make it look like this equation. I'm going to take it from vertex form and put it in standard form. Here's how we're going to do that. So we've got y equals 3x minus 4 squared minus 6. And this simply means y equals 3x minus 4 times x minus 4 minus 6. We can FOIL this out, or you can use the box method if you prefer, but I'm definitely a FOIL kind of guy. X times x is x squared minus 4x minus 4x plus 16, all in parentheses, still got that minus 6. Combine like terms, y equals 3 times x squared minus 8x plus 16. I still got that minus 6. Now I'm going to distribute that 3 all the way through to get y equals 3x squared minus 24x, and then 16 times 3, got a calculator, might as well use it, is 48. And I still got that minus 6 at the end. So now we're almost there. We're going to get y equals 3x squared minus 24x. Negative 48 minus 6 is negative 54. So the question is, for what value of c will the graphs of 3x squared minus 24x plus c equal 3x minus 4 squared minus 6? Well, that value of c is right here. So we can just say c equals negative 54 is the answer for that one. All right, write the quadratic equation containing the vertex in number 11 of 2 comma negative 12, or sorry, 2 comma 12, and the coordinate point negative 2 comma negative 4. So I know my vertex is at 2 comma 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's like up here. And the coordinate point negative 2, negative 4. So we need at least 3 points to write a quadratic equation. And it looks like I've only got half of the equation right now. But what you need to realize is that these things, these quadratics, they're symmetric. So if this point over here is 1, 2, 3, 4 from the axis of symmetry, I should be able to get another point by going over 1, 2, 3, 4. Because that's going to give me the other half of this quadratic. So my 3 points are 2 comma 12, negative 2 comma negative 4, which we were given, but then we've also got this over 1, 2, 3, 4. Sorry, 1, 2, 3, 4, 5, 6, negative 4. So that's what I'm going to want to type in the calculator here. I'm going to go stat, edit, type in the x values of 2, negative 2, and 6, and the y values of 12, negative 4, negative 4. And when you do stat calc 5, it's going to spit out an equation for you. It's negative x squared plus 4x plus 8. Y equals negative x squared plus 4x plus 8. That is the answer to number 11. Let's talk about number 12. Very similar question, just it's a word question. A man stands next to a river and throws a rock into the water. The rock leaves his hand at 8 feet above the water. It moves upwards and then down before splashing in the river. The rock is 23 feet above the water when it is 5 feet away from the man. The rock reaches its highest point along its path when its horizontal distance is 10 feet from his hand and 28 feet above the water. Write a function h to represent the height of the rock in terms of distance, the man's hand. So here, the distance is the independent variable, and the height is the dependent variable. So I'm going to write out some coordinate points, d, comma, h. The first one, when the distance from his hand is 0, it's 8 feet above the water. The rock is 23 feet above the water when it's 5 feet away from the man, so that'd be 5, comma, 23. And then finally, 10 feet away from his hand, 28 feet above the water. 10, comma, 28. So now we can write this equation, but I'm going to plug it in to stat edit. 0, 5, 10 for the x values. 8, 23, 28 for the y values. Stat calc 5. And I've got h equals negative 0.2 d squared plus 4d plus 8. That's the equation. So make sure if they ask you to write in terms of h and d that you use h's and d's in your answer. Number 13. The following is a student's attempt at converting from standard form to vertex form. The student has a vertex form of the equation written incorrectly. In which step did he make a mistake? What was the mistake? And what is the correct vertex form of the original equation? Alright, so I'm just going to go through here. It looks like in step 1 they just brought the 18 over to get the negative 18. I'm feeling good about that. I'm going to say step 1's good. Here they divided out the negative and they switched out all the signs. That looks right. I'm going to put a big check mark on step 2. Step 3, it looks like he turned the right side into a perfect square trinomial by adding 4. It looks like he added 4 to both sides. I'm feeling pretty good about that. Alright, then he just factored this thing, and so he cut the b value in half to get plus 2 squared. Okay, I'm feeling pretty good about that. Didn't change the left at all. Alright, now it looks like they're moving stuff over. Subtracted the negative 22 over there. I'm feeling pretty good about that. Last step, it looks like they got rid of the negatives, so he divided both sides by negative. Switched the sign on the 22, but forgot to switch the sign right there. So step 6 looks like the screw up. Step 6, what was the mistake? Forgot the negative before x plus 2 squared. So what's the correct equation? It should be y equals negative x plus 2 squared plus 22. Forgot to double check his work by graphing it. But you know better. You would have done that on the test. Okay, it looks like I've got one page left to do 14 through 19, and I'm going to do that in a third and final video. So we'll see you on the next one.